studies. In the quiet space haze of the maintenance hangar behind the terminal, a narrow-body aircraft in matte gray metallic.
The male engineer, aged 25 to 30, stood beside the wing, his eyes not on the surface, but as if reading through each layer of material.
We need to adjust the synchronization sequence for the starboard wing team. The current rhythm is slightly off schedule.
If an aircraft had perfect systems but a weak structure, could it fly safely?
And if the structure were extremely strong but the systems failed, could it survive in the sky?
The question is not which is better, but which determines survival.
In the white reflections across the aircraft, two worlds began to appear side by side.
One world is the system, where everything runs on logic and signals.
The other world is the structure, where everything exists through material and endurance.
The female engineer monitored the data, where each signal reflected the life of the aircraft. In normal conditions, systems ensure the aircraft flies correctly, stably, and responds precisely.
The structure ensures the aircraft does not break, deform, or fail under pressure. These two elements do not replace each other, but exist as parallel pillars.
One controls, the other endures.
One is intelligence, the other is the body.
In every flight, the system constantly adjusts every small detail.
Meanwhile, the structure silently carries all loads without a sound.
But if both are important, why does the question still exist?
Wait, look at the trajectory data.
The altitude parameters are spiking. We need to isolate that signal now.
It was not a major error, but enough to draw her attention.
I found the distortion you mentioned. It's subtle, but it's definitely here.
Okay, I'm documenting the coordinates now.
They looked at two different problems, yet felt the same realization.
One could be corrected through software and adjustment.
The other was a sign of material fatigue that could not be reversed. The difference became clearer when one could reset, while a crack could not heal.
Does that mean structure matters more?
Or is the system what determines whether danger can be avoided?
The male engineer placed his hand on the metal surface where pressure had accumulated over thousands of flight hours. He understood that structure does not only endure force, but also time. Trajectory stabilized, rerouting power to the auxiliary coupling.
Predictive metrics are dropping. Looks like we're clear for now.
She understood that the system does not only operate, but also protects. But systems can only function when the structure remains intact. And structure only matters when the system knows how to use it correctly.
If the system fails, control is lost.
If the structure fails, existence is lost.
One is loss of direction, the other is loss of physical existence.
In extreme situations, neither can replace the other.
The female engineer began deeper analysis to understand how systems react to structural changes.
The resonance frequency is peaking right here at the seam.
Confirmed. The strain gauge readings align with your observation. They realized systems and structure are not separate, but constantly interacting. A faulty system can impose excessive stress on structure. A weak structure can distort system performance. There is no clear boundary between the two in reality.
The difference exists only when separated for analysis. In real flight, they merge into one living system.
Thus the question of which matters more begins to lose its simple meaning.
It is no longer a choice, but a dependency.
The male engineer looked at the fuselage, where each rivet holds the structure together.
The female engineer looked at the screen, where every line of data keeps the system stable.
They no longer searched for a simple answer.
Because an aircraft does not fly by a single element. It flies by the perfect balance between control and endurance.
The surface stability is holding perfectly, even with the simulated turbulence. It's remarkable synchronization. The system adapted instantly. The structure allows the aircraft to withstand what it must face. Without intelligence, there is no control.
Without endurance, there is no existence.